track. I'm prepared to introduce Dr. Tim Eden from Penn State if he's ready.
Okay, so I'd like to thank everyone for listening, and I had to, in order to get some clearance things, I have to modify my talk a bit to get it through. So I'm just going to go through and talk about some things in general that we're doing that have supported NAVC and try to hit some of the highlights that we've learned. So if you want to go to the next slide. Okay, so since the last CSAT, they combined at Penn State, they combined the materials processing division, which I had, and the additive manufacturing. And so this is just a slide. So now additive manufacturing is under the material science division, and I became the division head of both of those. And so what that does is that brings the additive manufacturing and cold spray under the same umbrella, and we can start be a little bit more synergistic in the way we move forward with those activities. And so I decided I'd let you know that's what's happened at Penn State. If you want to go to the next slide. So this one is a slide at which we've learned in how we've supported NAVC and ONR. And we started out with process development with spray parameters and processing, and they talked about this qualified spray procedure, a QSP, and what we're doing is when we found out in talking with the shipyards and different people that there's an ASTM spec, but we wanted everybody to try to use the same standard operating procedures, same test procedures. We've provided a list of equipment that you use when you do those qualification testing and try to standardize it as much, and we're supporting the shipyards as they go out and they do their QSP and their spray qualifications. And one of the things that in this process qualification, doing the QSP work, is that you have to get certified by NAVC in order to be able to perform repairs for NAVC. And as mentioned by Jeff Campbell, that was done through Carter Rock. And that's an important point for vendors that want to support the cold spray development. So in education and training where we're working, as we've developed courses, we have slide decks for engineers and technicians, and and have some lab training. We've presented those to a couple of the shipyards when they were at Penn State, and those interactions are really critical for us because we start out with our standard procedures. We start out with our training, and we use the shipyard as guinea pigs to tell us what, they try to use our procedures so they can modify them to make them work. It helps us understand what they need to do. It helps us understand the language that they speak and the information that we need to provide. And we've had a number of people come in, and we've had them, they've come in, they brought their parts, they've set up the robot programs, they've done the hand spray on those. And so they, at the same time as we're learning from the shipyard, the personnel, they're learning about the limitations of cold spray. They're learning about what they want to do and how to do it. And people get a really good feeling. We go through redo a powder feeder, go through powder handling, go through the whole process of cold spray from a, kind of a little bit higher level. So right now I have a PhD student, Bob Brown from NRL. He came to Penn State, got his courses in, continues to work for NRL, and he's doing some corrosion and post-processing cold spray coatings. We have another PhD student that's working at the Applied Research Lab. He's focusing on nozzle fouling. In the shipyards, we do the QSP testing for them. We help them with powder selection. We do troubleshooting. So we just had, or this week we're getting our training on the robot from ABB, and we're finding out a lot of things about how to interact with the spray gun and the robot, and learn quite a few things about tool center points, and so it's been a really good thing that we'll be able to pass that information along. when we're doing the NDE work. We're working with Carter Rock, looking at ultrasound, eddy current. We do have a CT system at ARL, so we're looking at how we're doing that. We have a corrosion lab where we do a lot of testing. We're moving into structural repair, and that's with Jen Walk at ONR, structural repair of high-strength aluminum alloys. We've done a lot of handheld deposition, and we've shown that our technicians that a couple of them can get really pretty good results. They're similar to the robot sprays, and they're consistent. We're also doing some analysis and modeling to support the effort. If you want to go to the next slide. So in the qualification testing, and this is work that Tom Stamey did an excellent job in putting this together. So there's a non-sealing or non-bearing surface. So there's a minimum wall thickness. You have another category where you're a sealing or a bearing surface. Then you have one where you need to restore some wall thickness, but it's really loaded in compression or shear. And then they have one that's the last one is essentially a structural repair. And so in the Navy, you have corrosive environments, non-corrosive environments. So corrosive environments would be seawater, other fluids. You have static, dynamic. There's different testing that applies to those. And then when you do the based on your subcategory and category, then you have to do a number of tests. You always have to do the microstructure. You have to do the adhesion and corrosion and wear. And I just showed on the right, some of the microstructures that we've done, show a wear scar. And if you want to go to the next slide. So this is kind of what we pulled out from the testing, and not all of these are testing, but you follow applicable mill specifications, ASTM standards, the number of samples that you want to look at, then you look at the criteria for acceptance, and the number of samples that you need, and really to go through and do a test or a QSP, it involves several hours of setup. This is producing the sample, setup, testing, analyzing the data. So you're looking at maybe 30-ish hours if you have to do all those tests. And then, for the corrosion and for the wear tests, you need some specialized equipment to do that. And one thing that's noted here is on the open circuit potential, the potentiodynamic polarization, and the wear testing. Those are, in a way, are subjective results, so that you need to have somebody with experience that can look at those results and determine if, really interpret those and make sure that those are following and they meet the criteria. And so we have a list of all the equipment that's required to do those tests. And we've also, we support the Navy, the shipyards, in doing any of these testings that they need help on. We're providing those standard test procedures that we use, and we also help them interpret results and explain to them what's going on, so that the next time they do the test, that they're able to understand that. The next slide, please. So this, based on the work that we're doing with the hand spray and with the RIF and the Phase 2 SBIR on working portable development, portable cold spray repair, we looked at it and said, doing the cold spray repair is just one part of the repair. And what we wanted to do was to have a system that we could put on a robot if needed, a small robot that could be hatchable, that you could put down and you could have it do different things. So in the process now, and we're always trying to use commercial off-the-shelf technology. So we use a LiDAR scanning to come in, identify the surface. You could throw a high-definition camera on there. We can come in, we have a grinder and a wire wheel and some hand tools that are actuated by the robot. So you don't have to have them connected. We can do the plasma blast. We can do laser ablation. Through a program with the Army, we're developing a head to do laser deposition using the portable robot. We're working with, having an ultrasonic eddy current system developed. We have quick disconnects, so it's less than it's about 30 seconds to change out the technology. We're having a common power supply that all you need is one power supply out to the system. Jazz mentioned it'll be in a container that can be transported. We'll have a common computer system to collect all the data, and we're making it so that you can interface with different types of robots, and all you need is to specify certain pieces of information from the robot. And we want to do this, and we're going to do a technology demonstration. And I wanted to finish in 10 minutes, so I've done 10 minutes, so I'm done.
Okay.
Any questions?
Thank you, Tim. Yeah. So we had a question come in regarding fatigue testing and corrosion testing and combined testing. So I guess specifically sensitivity of the results to the cycle time of the corrosion versus the stress field.
So we have not done that yet, but that's something that we're going to be doing in the next, we want to do that in the next field. We found that with the potentiodynamic and the open circuit potential, it was a little bit more involved in the corrosion testing, and so we're trying to build up a bigger database of the, over a number of samples to get an understanding of the non-stress field, and then this year we're going to move into the doing those tests in seawater or another type of corrosive environment.
All right, and one other question about the CFD modeling. Is the CFD modeling the cold space system modeling and analysis that you're working on, or is it something else?
So
is it system level, I guess?
So the answer is, like everything, is eventually. So the CFD modeling that we're doing is for our, the PhD student. He's going to be looking at nozzle fouling. So we're going to use the CFD modeling to try to figure out, what, where the nozzle fouls, what different types of powder, what different parameters do on that. And then eventually, once we, when we understand that, then we're going to move to have that be part of a system modeling effort where, and maybe you guide the placement, or maybe you change the powder feed rate based on your material and based on your flow parameters. So right now it's pretty specific on the fouling, but the next step will be to make it a global system model.
All right, sounds good. Well, that's time. So thank you very much, Tim. And I'd like to ask Isaac Nault